All right, matrix inverses. Okay, first, before we get into the inverses, we've talked briefly about the identity matrix, but the identity matrix is a square matrix that has a diagonal of ones with zeros everywhere else, and it could keep going on. You could have a 5 by 5 or a 20 by 20 identity matrix, but that's what it would look like. It's called the identity matrix because if you multiply any matrix by the identity matrix, then the original matrix maintains its identity. It doesn't change. So matrix A times the identity would still be matrix A. It doesn't change. So that's what the identity matrix is. Inverse matrices, is denoted as A to the negative 1 power, but you actually read that as A inverse. But the inverse of matrix A is denoted that way. And when you multiply matrix by its inverse, you will get the identity matrix as an answer. So a matrix times its inverse will give you the identity matrix. And to find the inverse of a 2 by 2 matrix, we simply follow this formula. There is another way we could do it, which I'm going to talk about in just a minute. But this is how we would find the inverse of a 2 by 2 matrix. So we start with A, B, C, D, then you use this formula right here. So let's do the inverse of this matrix right here. So A inverse would be 1 over, and then it's A times D minus B times C. So we multiply going down, negative 1 times 2 minus 3 times 4. And then you multiply that constant through the matrix, and then we swap the A and the D. So we're going to swap negative 1 and 2. So we'll have 2 and negative 1, and then 3 and 4 will become negative. So that'll become negative 3, negative 4. And then we start cleaning that up. So negative 2 minus 12, that's going to be negative 14. So we have 1 over negative 14 times the matrix 2, negative 4, negative 3, negative 1. And then when you multiply that through, you simply multiply each element inside the matrix by negative 1/14. So that would be the matrix 2 over negative 14, negative 4 over negative 14, negative 3 over negative 14, and negative 1 over negative 14. And then I'll clean each of those fractions up, the ones that reduce. 2 over negative 14 is negative 1/7. 4 over 14 is 2 over 7. 3 over 14 doesn't reduce, but the negatives will cancel, so 3/14. My writing is atrocious. There. And then the negatives cancel on that one to leave you with 1/14. So that is your inverse, and usually inverses are ugly. That's just kind of the nature of the beast. So this would be your inverse for the 2 by 2 matrix right here. And one way you could check it is you could multiply this matrix by the inverse, and you should get the identity as a result. If you want to verify that 2 matrices are inverses, so here I'm giving you 2 matrices, and I want you to show me that they are inverses. So what we're going to do, we have 2 options. All right, one of our options is we could simply find the inverse of matrix A and see if the answer we get is matrix B. The other option is we could multiply matrix A times matrix B and see if we get the identity matrix as a result. And that's what I'm going to do. So let's take matrix A, and then we will multiply it by matrix B using matrix multiplication and see if we get the identity as an answer. Now remember, when you multiply matrices, this is a 2 by 2, this one's a 2 by 2. The inside numbers do match, so I can multiply, and I should get a 2 by 2 matrix as an answer. So let me go ahead and get my blocks ready. Okay, and then I start with row 1 of the first matrix times column 1 of the second. So negative 3 times 1 and 2 times 2. That would be plus 4, wouldn't it? And then I would do row 1 times column 2. So negative 3 times negative 2 is 6. 2 times negative 3 is negative 6. And then I'll do the second row by the first column. Negative 2 times 1 and 1 times 2. And then the next column. Negative 2 times negative 2 is 4. 1 times 3 is negative 3. And then we will add those together. So negative 3 plus 4 is 1, 6 minus 6, negative 2 plus 2, and 4 minus 3. And I did get the identity matrix. Therefore, we know that A and B are inverses of each other. Okay, good. So that's how you verify that a 2 by 2 or two different matrices are inverses. If you have a larger matrix, if you have a 3 by 3 matrix, the way you would find the inverse of it is much more difficult. What you would have to do is you take your original matrix and you augment it with the identity. So we create this huge matrix where this is your first one, you put the identity matrix next to it, and then we do that Gauss-Jordan elimination, the row operations, and we want to turn this into the identity matrix, and the original identity matrix will turn into the inverse as you go through those row operations. It's a very painful process, and because of that, we will do 3 by 3 inverses on a calculator. We're not going to do those by hand. By the way, you could also use this method if you wanted to be really difficult. You could do this method on any matrix. So I said of 3 by 3 or larger, but this would actually work on a 2 by 2 matrix if you really wanted to make your life difficult. But we're going to do these things on a calculator. So that's all there is to those. There, pop that in there. We'll do these on a calculator, but just so you know, that's how you would do it. And that's it. Thanks.